Yes, welcome to my video lesson. Dear students, we have gone through several classes. We have completed a few lessons, and this is the second lesson on this week. And we were discussing lots of things that is clearly connected with GIS and how the GIS important, and the link between GIS and geography. Of course, geography and GIS really something what it will go in hand, fine. And we are using the geographers, planners, cartographers, and so many other people, administrators, all are using this GIS for better analysis, and we are using this GIS for problem solving, fine. Different problem solving that is connected with geography, fine. Spatial problems, we are solving the spatial problem. So see, I already said cartography, that GIS is more linked with cartography, and the cartography is the heart of geography, and GIS is the language of geography. And we people are regularly studying about spatial process, spatial pattern, and spatial behavior, right? We people are predicting, and we people are studying, right? Scientific study. So here we are starting a new lesson. We already completed spatial thinking, the concept of spatial thinking, and most important concepts in geography, and most important themes in geography, and so many things, fine. And we already know what you mean by GIS. It is nothing, collection of spatial data, storing the spatial data, manipulating the spatial data, then analyzing the spatial data, and displaying the spatial data, means geographical data. That is the what that is the work that is done by the GIS, geographic information system, right? And nowadays it is something like a GI science, right? It is known as GI science, and or spatial information technology, or spatial information science, or spatial informatics. You are in different names. Okay, so that collection, storing, and now analysis. So in that analysis, in prerequisite, I have taught two lessons, that is themes and concepts in geography. Then spatial thinking, fine. And we people gone through different things that is clearly connected with point, polyline, polygon, vector, raster, topology, fine. And so many things. And today we are going to do a lesson that is connected with spatial analysis, part one, right? So in that one, overlay analysis, mainly in that basic analysis, there are three types of analysis, that is overlay analysis, buffer analysis, and network analysis. And today we are going to discuss about what you mean by spatial analysis, and that what you mean by overlay analysis, and what are the different types of overlay analysis, right? So let us start our lesson. So the spatial analysis is nothing, analyzing the data for better results, to find certain geography, to resolve certain spatial problems. So spatial analysis is a process in which you model problems geographically, derive results by computer processing, and then examine those results, explore and examine those results. Several fundamental spatial analysis works goes from the heart of spatial analysis, spatial data exploration, modeling with GIS tools, and spatial problem solving. So overlay analysis, you can see easily, you can understand what is that overlay analysis means. We are overlaying different layers, a combination of different data layers, both spatial and attribute data is combined. Requires that data layers use a common coordinate system, a new data layer is created. Right? You know that what you mean by coordinate system, what you mean by projection, and those things that already you people learn. Right? So this is something, a pictorial representation of this data. Is all are pictorial representation, certain mathematical calculations. Then vector, you know that what you mean by vector and raster. Right? Vector data that is stored in that point, polyline, and polygon, fine. So vector overlay, Topology is likely to be different. Vector overlays often identify line intersection points automatically. Intersecting lines are split and a node placed at the intersection point. Topology must be recreated for later processing. Any type of vector may be overlaying with any other type of output, typically takes the lowest dimension of the input. For example, point on polygon results in a point. Fine. We will see if we are getting a practical session. I will teach you these kinds of things. Fine. Then this is a mathematical representation. We have seen the same diagram. And vector overlay, there are three types of vector overlay, that is clip, intersection, and union. Clip means we are clipping one part from the data. Intersection means inserting one. Union means merging so many data together, vector data together. Fine. So vector overlay, most common way is applied, but there are other methods, mainly that clip, intersection, and union. So there are three methods, that is clip, intersection, and union. So clip, cookie cutter approach. Bounding polygon defines the clipped second layer. Neither the bounding polygon attributes nor geographic spatial data are included in the output layer. So that you can see that clip, how the clip is working. Fine. The first one. Fine. So you can see the that clip. Fine. How the that bounding layer, data layer, and output layer, how this one is connected. This red mark. Right. This is the way we people are extracting the information. Fine. It's clipping. Fine. Clipping a layer, particular what we are necessary. Right. We will use different methods in if we are in front of that desktop, I can show you certain other methods. It is just theoretical explanation. Clipping certain layers, that may be point, polyline, or polygon. Fine. And it is also a pictorial representation. See how the output layer is coming. Fine. Input layer, that processing, and output layer, how they are extracting the output layer. Next one is intersection. Combines data from both layers, but only for the bounding area. Bounding polygon also define the output layer. Data from both layers are combined. Data outside the bounding layer, first layer, is discarded. So the second one, how the data is intersecting. Right. How the data is a polygon, certain point data. There is no polyline data. Fine. How the see this red mark. See the red mark here. We are intersecting certain polygon. Fine. With certain another polygons. Fine. Smaller polygon inside polygon. Fine. So this one is the output data. Fine. So it's just mixing. Fine. Clipping means extracting. Intersect means intersecting. Fine. Intersecting certain layers, and this one is the output data. Fine. How this one is connected. See that old maps for better understanding. We are clipping and intersecting the details. Next one is union. Union means we are merging point, polyline, and polygon. Whatever it is, you can merge what kinds of vector data. Any kinds of vector data you can merge. Any kinds of vector data includes all data from both the bounding and data layers. New polygons are formed by the combination of the coordinate data from the from each layer. See this third one. This is the union function. That 1, 2, and 3. This is the end result. We are merging all the details at polygon, point, and polyline. See, this is also a result. Okay. So see, in that one, simply how we can explain. For example, if you are preparing a map, that may be that our college, government college too. So first we will prepare a single polygon, that is the whole area, that highest polygon. Then we can mark this ground as a polygon inside the polygon. Then hostel, other departments, main block, all are marked, let us mark as a point. So now how many layers? One polygon, that is the main polygon. Then inside that ground, that is a single one more polygon. Then all these point that is hostel, women's hostel, that other departments, main block, all those things we can mark as a points that I have shown in that video. And next one is let us mark the road, that road running through that college, that is the linear feature, polyline feature. So we people are merging. That is a simple example for overlaying different different data, different kinds of vector data together. For that one we are using different method, that is clip, intersect and union. Fine. So next one is erase. So that it is also connected with this is not much important for you people. Erasing is nothing, it is just erasing one part. We are selecting one polygon and erasing with the help of software. Fine. Then identity analysis, these kinds of things is not much important for you people. You can it's that three method, overlay analysis and three method, that is the important things for that BSc degree. Fine. You people just learn what you mean by that. For your class. Fine. That three methods that is involved in the overlay analysis. See, three methods involved in overlay analysis, that is clip, intersect and union. Fine. How these functions are important for your data analysis, overlay analysis. Right. How this one is merging, how this intersecting, and how we are clipping. Right. So that erase and all those things, it is not much important for people. So hope you people are understanding my lessons, and a few people are giving regular feedback, certain certain regular assessment. Some people are regularly attending the assessment. So kindly cooperate with like this, continuing your cooperation. And okay, a few people are not attending the assessment. Let us see what will happen. Fine. Let us see that how to manage things, how to manage, and going ahead. Right. Anyway, that I think most of this lesson will continue like this online only, I think. Next one is buffer analysis session. So keep going. Try to understand the concepts related with overlay analysis. Ask your doubts. Right. This is the second lesson, and next one is buffer analysis. And I will upload next video on that in today evening itself. Right. So ask your doubts and cooperate with the lessons. So thanks for watching. Thank you. Thanks a lot.